Okay, question 5. While first rationalizing the denominator, or otherwise prove this. Okay, so what do we do first? We first rationalize the denominator. Right? What do we do? Our first step. Thank you, Belinda. It's fine. Our first step now is to rationalize the denominator. Recall, how do we usually rationalize? We make use of the fact that here a plus ba minus b. So what do? We multiply by this fraction here, which is essentially 1. But recall the idea of rationalizing. This is a plus b, this is a minus b. So this is, you change the sign to a minus. That's the main idea. So there's nothing wrong in multiplying by 1 here. So far so good. Okay, fine. Thanks, Sarah. Okay, is everybody following so far? Type okay if you are following. Okay, good. So when we rationalize, we will then see that the denominator is making use of the idea a plus b, a minus b. Denominator becomes a square minus b squared. So it becomes this. And it becomes quite nice. And you realize that the denominator actually becomes 1. And it's just that. Alright? So something complicated in the denominator has now appeared in the numerator. Interesting. So anyway, it's guided. So don't panic. Just follow instructions. You should be able to get to this stage. Okay? Now, next. The question asks us to find the summation. So we just write down the summation of this. And earlier, you have found that this expression is exactly the same as this expression here. Alright? So it is not difficult then to write this down. Just replace the thing in the summation sign. No big deal. Fine. Alright? So now you realize that this within the summation, it is a difference. Alright? There's something minus something. Right? You see root n minus root n minus 1. Then you would suspect that you will use MOD. Method of difference. So then we list out n equals to 1, you get root 1 minus root 0. N equals to 2, you get root 2 minus root 1. Root 3 minus root 2. And of course, we must put dot 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 and the last few terms. So at least write down first few terms and last few terms. Then you can see the pattern of cancellation, which is then very simple. This way, this way, this way goes, this way goes, and this way goes. And you get root n. Sure. Done. Simple enough. Okay, this part is the easy part, am I right? It's the second part that's difficult. Okay, anyway, so far so good. Type okay, we are okay. Belinda, okay? Good. Let's move on. This is the difficult part. Okay. This is difficult. Why do I say it's difficult? Because look, you want to deduce or prove otherwise, that you see you have an inequality. From earlier part, you have an equation. Now you want to prove an inequality. And furthermore, you see here, within the summation here, there is only 1 over root n. But earlier, you have this thing, 1 over square root n plus root n minus 1. So there are many things that are different. So that's where it's tricky. It's extremely difficult. But what we should be very clear is it is definitely linked to the earlier part. For sure, it must be linked. So we should draw some links. Try and draw some links. Okay, don't ask me how yet. Don't ask me how I came out of the first step. I'll explain it later. Okay, be patient. I'll explain it later. So my first step is this. For all n greater or equals to 1, root n minus 1 must be smaller than root n. Of course, root 5 is smaller than root 4. That's right. Root 4 is smaller than root 5. Sorry. Root 4 is smaller than root 5. Root 5 is smaller than root 6. And on and on and on. So far so good. Okay, I'll explain why I come up with this first step later on, okay? Fine? Okay? Okay, next. I'm going to add root n on both sides. Okay, I'm going to add root n on both sides. So I add root n here, and root n plus root n, I get 2 root n. Now, this is where you can see some link soon. Alright? So you can realize that actually I came out of inequality now, and I can see something appearing here which looks like this. Now, then, next thing is I see a reciprocal here, but I don't have a reciprocal here. Alright? And we also need to realize that this is positive number. And positive number that is greater than 1. This also must be a positive number greater than 1. So just take as an example, if 4 is smaller than 6, if can I say 1/4 is greater than 1 over 6, provided 4 is a positive number greater than 1 and 6 is a positive number greater than 1. So notice that I changed the inequality sign. Alright, so next step will then be this. I take reciprocal, but now I change the inequality sign. So now I have this inequality. Again, take note that the inequality sign is changed. Now we can see something. We actually want summation, look here, 1 over root n. But I have 1 over 2 root n. Is it difficult to link? At this point, it shouldn't be too bad. So I divide, or rather I times 2 on both sides, and I change it around from here to here. I change the left hand side becomes right hand hand side becomes left, and I multiply by 2 on both sides. So I deliberately make this 1 over root n appear. Then I apply the summation sign on both sides. Okay, so from this step to this step is not too bad. I just apply the summation sign here, summation sign here. Same thing. I sum from n equals to 1 to big N. Now, then, what is this thing which was found earlier, right? because this was found earlier. It's just that this is 2 times of this. Therefore, if this is smaller than this and this is 2 root n, I think the result is out. All okay. Okay, Sarah's question. Okay, good question. I'll answer that soon. Which part, Belinda? Okay, last line. Okay, last line again. Can you hear me? Somehow my internet connection is not very stable. Okay, hang on. One question at a time, okay? Can you hear me first? Hello? Hello? Hello, hello. Are we okay? Can you hear me? Can you hear me now? Okay, good. Okay, now, where did the, one thing at a time, okay? Where did the 2 come from here? From here to here is at root n on both sides. Alright? And how do we get this last line? I can add this, to answer Sarah's question, can we add the summation on both sides like that? Yes, the short answer is yes. It's fine. It's just like saying, if r is greater than r minus 1. Alright? Can we say summation r equals 2 to 4 is greater than summation r equals to 2, 4, r minus 1. I think it makes sense, right? Since individual terms are already small, greater than, so you sub 2, it will all be greater than. So we can safely say so. Sarah, okay. Okay. All okay. Belinda, Jeanette, all okay. Okay, then I go back to this question, yeah? Why did I start off with this line? How did I come up with this line to kick everything, to kickstart everything? This is the most important step. How did I realize that? How do we all realize it? Now, it's a very difficult question to answer. Extremely difficult. All I can say is we have to spot that you need to prove an inequality. You need to prove an inequality. So somehow you have got to introduce an inequality. And how did the inequality come in? You have to draw the link between this and this. The root n and the denominator of this, which is root n plus root n minus 1. So that's all I can say. Alright. I know it's extremely difficult. Don't lose sleep if you cannot come out of it. But if you can understand, I think I'm happy enough. Can? All okay? Can we move on? Okay, good. Question 6. Question 6 is another tedious question. Using this result, find the sum of the series. What is this result that we're talking about? Look here, you have to reuse, you see a sine cube A. You see sine cube A, you see sine cube theta. So somehow you got to make use of this. So what I'm going to do is I divide both sides by 4. Divide the result that they want us to use. Divide both sides by 4. Now, which means that if I use theta, let's do one term at a time. If it's sine cube theta, it will be 3/4 sine theta minus 1/4 sine 3 theta. Very simple, I just make use of this guy. Alright. Can we make use of this same line here? Or for this second term, which is here? I think we can. It's just that there is an additional 1/3 factor. So 1/3 times 3/4. I get this. Alright, this one is 1/3 times 3/4. This time your A is 3 theta, so sine 3 theta minus 1/4 times 1/3 sine 9 theta, because A is now 3 theta. Type OK if you are following. Shout for help if you need me to slow down. Good. Okay, I wait for a while, okay? I just let A be 3 theta. It may help if you write down as well. Okay, and this 1/3, let's not forget the factor 1/3, okay? The rest okay? Okay, Christine, what's your question? Okay, fine. Okay, let's try and do this together, okay? Using this idea, let's rewrite this, okay? 1/3 something. Right? What is sine cube 3 theta? Because I know what is sine cube A. So therefore, it will be 3/4 sine 3 theta minus, sorry, no space, 1/4 sine. Now, recall A is 3 theta, so 3A is 9 theta. So now, if I multiply the 1/3 into 3/4, I'll get this 3 over 3 times 4. There's a reason why I write it this way. Later I'll explain. 1/4 times 1/4 I will. Okay, if you get it, I think you can try and write the next line. Alright, the next line, I think it will really help. It will really help if we try and write the next line. The next line actually, even though it's not given in the question, we should know what is the next term. The next term should be 1 over 3 square sine cube 9 theta. Am I right? Which is actually equals to 1 over 3 square 3 over 4 sine 9 theta minus 1/4 sine 27 theta. Am I right? So therefore the next line should be this. Is everybody okay now? This third line. Okay? You should be able to write the third line on your own. Okay, excellent. Very good. Now, the tricky part now is we should write the last, at least the last 2 lines. I don't think the last line is good enough. Let's try and do the second last term. The second last term, we should try and do it this way. Again, the second last term is not given in the question, but I think we should all know. The second last term is 1 over 3 n minus 1 sine cube 3 n minus 1 theta equals to what? 1 over 3 n minus 1. Sorry for the bad handwriting. The writing is not. To answer Shi Ming's question, yes and no. Yes and no. But you will find it a little bit more difficult to write the last 2 terms. Maybe the first few terms you can still see the cancellation pattern. Alright? We'll get back to the second last term. Then you will get, sorry, should be 3, yeah? 3/4 sine 3 n minus 1 theta minus 1/4 sine 3 theta. No, 3 n theta, sorry. Okay? Then you multiply this in, you will get the second last term, which is this. And you get the last term, which is this. I'm going to pause for a while now. Make sure you understand and you should be able to write them down. Need time to think? Or can I carry on? Can. If you factorize the 1/4 out, then you will always have a 4, which is maybe neater, I must admit, yes. Jeanette, that's a good suggestion. If you factorize the 1/4 to create the 4, that's fine as well. That's good. That's fine, Jeanette, that's good. Oh, you mean the last term? Okay, the last term, the nth term. Because, let's look at it very carefully. Belinda, for this last term, your A is 3n theta, right? So now you have a 3a. So 3 times 3n theta, you get 3 to the power n plus 1. Okay? Belinda, okay? Okay, the rest okay? Phoebe? 诗明 what happened? 3 over 3. Oh, this line. Oh, Shimin, you were talking about third line. Okay, I must say the third line came from the third term. Third term wasn't written. I'm just trying to add more term to see pattern. Okay? Okay. Now we should be able to see that, look here, you have 3 theta. If I have this 3 and this 3 and the 3 should cancel, and then therefore these two terms goes. These two terms goes. This term goes. This term goes. This term goes like that. And now you can see that it is a nice expression. Okay, now I'm going to pause here for a while. All okay? All following? Good. To answer Phoebe's question, so it starts from 3 to the power of 0. I suppose you could say that. Yep, fine. Okay, the very last part, which is, again, is always difficult. I think, okay, we need to deduce. Now, let's check first, Deduce from what? From earlier part, we have shown this. Okay, this is from just the earlier solution. Okay, from earlier part. The left hand side equals to right hand side here, which was the answer from this earlier part. Alright. Now, then you look at what you need to deduce. I would take note of a few things. From a Q, I now become a square and I have an additional cosine theta. Correct? From a sine theta now becomes a cosine theta. From a sine this theta, I get a cosine this theta. Ooh, I think there is only one operation that can do all these at one go. Of course, if I tell you the answer, it will be quite obvious. Because as the giveaway is actually here, from here to here. How do you get a cube to a square and yet you have a cosine theta? That is chain rule application, right? From here to here. If I differentiate both sides with respect to theta, I should get the answer. Are you all following? Are you all following? We worried now. But, oh, we are. What is this? Loss. Okay. Okay. Again. The blue one is what you have shown earlier. The black one is what you want to deduce. Okay? Okay? Is what you want to deduce. I'm going to spot some pattern. How do I get from the blue line to the black line? Okay? I said just now, from every term you see a sine cube. Now the black line has a sine square and a cosine theta. Again, I have sine square. Second term also sine square, cosine something. And then the right hand side here, the corresponding right hand side, I have a sine theta. What I want to prove has a cosine theta. Okay? Can you hear me? Is everyone okay? I fear this kind of silence. Okay. Okay, good. There's some response. And you see from here, sine, you get a cosine. So the only operation we ought to do now is to differentiate from the result earlier. I differentiate both sides, left hand side and right hand side, with respect to theta. And then the answer is out. Quite easily, within 2 lines, the answer is out. When you do it on your own, you should be able to get it. This is the key. This is the key. Can multiply by cotangent. Cannot. You multiply by cotangent theta or cotangent 3 theta or cotangent 9 theta. Yes, absolutely right. But then I think you answer your own question. Okay, so you differentiate and you realize that the left hand side is just, and the right hand side are both this. Okay, you can differentiate on your own. The only thing that is extra is now the 3. You divide by 3 on both sides, you will get the result quite easily. Two-liner and we're done. Absolutely, that's what I said just now, Phoebe. Yes, and furthermore, you have an addition. For a cube theta, for sine cube, it became a sine square, and as an additional cosine, you know that that is the result of chain rule. No. You type okay, we are okay. Okay, good. Okay, those who type okay can go. Done. Thank you. Have a good weekend rest, if any. Okay, take care. No problem. Thank you. Good night. Don't sleep too late. Thanks, Jimin.